The discussion begins with a reference to a cosmological model that closely aligns with the concept of a Big Bang. The Big Bang is brought up and emphasized that this event did not represent the beginning of the universe. Numerous aspects of the universe have been revealed, such as dark matter and stellar systems. Observations and research in the field of energy played a pivotal role in enhancing our comprehension of the universe's formation and its ongoing expansion. Recently, however, the James Webb Space Telescope has found something surprising, a discovery that may pose a challenge to the accepted model explaining the universe, even questioning the evolution of the cosmos. What are some fundamental laws of physics? What exactly was discovered, and why does it have such profound implications? In this video, we will delve into the implications this discovery has on our comprehension of cosmology and its significance for the scientific community. The image captured by the James Webb Space Telescope has radically improved our comprehension of the cosmos, shattering long-established views of the universe's evolution. Gaining an understanding of the immense universe has always been of vast importance to humankind. Our curiosity about the origins of the world around us has aided in the growth of fields such as astronomy and cosmology. Through these fields, we have gathered extensive knowledge about space and the remarkable phenomena within it, including evidence that the universe does not display a uniform distribution. Certain regions of space demonstrate higher densities than others, a phenomenon that lends credence to the Big Bang theory. The Big Bang theory is the current scientific justification for the origin of the universe, arguing that the universe began as a single enormous explosion, followed by its growth. As a result of cooling, several phenomena support this theory, including the cosmic microwave background radiation, CMB, which emerged after the universe's first moments and is often regarded as an echo of the Big Bang. The CMB has existed for over 13.8 billion years and holds valuable clues about the early universe. Over the years, theories explaining the evolution of the universe have undergone significant shifts, brought about by new discoveries and advancements in research and technology. These findings have prompted necessary modifications to existing theories and, at times, the creation of new ones. The James Webb Space Telescope's primary objective has been to provide sharp images of space far beyond our planet, as well as to explore the most distant regions of the cosmos in search of stars and galaxies that formed soon after the Big Bang. By studying these celestial bodies, scientists can gain a deeper understanding of the processes that resulted in the birth of stars and planets and acquire insights that could either expand or refine the Big Bang theory. Technological advancements have enabled researchers to introduce concepts like dark matter, dark energy, and the ongoing development of the universe, all in line with the Big Bang theory. The idea of universal expansion suggests that the universe is perpetually expanding, with galaxies and galactic clusters moving farther apart. This process is believed to have been ongoing since the universe's inception around 13 billion years ago. Scientists propose that dark energy, a mysterious force, is responsible for this expansion, while dark matter, though invisible, plays a crucial role as well. Over the years, numerous approaches have been developed to detect or measure dark matter in space. The James Webb Space Telescope has proven invaluable in this regard, providing high-resolution images that let astronomers determine how much dark matter exists in specific areas of space. In addition to these efforts, gravitational lensing, which explains how space is distorted by massive objects, contributes to our understanding of dark matter in the universe. Recently, the James Webb Space Telescope has contributed to a number of remarkable discoveries, one of which entails the detection of objects resembling planets within the Orion Nebula, a well-known region of space in our galaxy. Earlier studies had not identified such objects in this cosmic dust and gas cloud until this discovery was made possible by the Webb telescope. These findings are only a glimpse of the many outstanding revelations the James Webb Space Telescope has recently brought to light. However, one discovery stands out as particularly troubling. The impact of this finding has significantly challenged our conventional understanding of cosmology and astronomy, as it suggests a scenario that may call into question the validity of the Big Bang theory. What exactly did the James Webb Space Telescope uncover, and why has this discovery caused such a shock to the foundational principles of cosmology and astronomy? The James Webb Telescope has recorded the disappearance of over 771 trillion solar systems, an event that appears to defy a fundamental law of physics, the conservation of matter. According to the conservation law of mass, mass cannot be created or destroyed, but it can change from one form to another. Since research on the universe has always relied on such principles, scientists now face the challenge of explaining the sudden disappearance of whole solar systems made up of stars and planets. Were these systems destroyed, or did they simply change in some undetectable way? Some experts have suggested a plausible theory, that the disappearance of these solar systems could be due to a transformation of their mass. In this scenario, the stars and planets may continue to exist in the cosmos in forms that we are currently unable to detect. This theory is backed by events that occur as stars age and can no longer hold on to their gases. Supernova explosions are the result. During these explosions, stars unleash their mass throughout the universe as tiny particles. Some scientists speculate that something comparable could have happened to the solar systems that vanished without a trace. Despite this possibility, the majority of the scientific community remains skeptical, since stars do not typically disappear without leaving any evidence, particularly without going through a massive supernova. The disappearance of trillions of stars should have had a significant influence on the entire universe, including our Milky Way galaxy. Another theory suggests that black holes might be responsible for the sudden disappearance of these stellar systems. Black holes are regions of space with extremely high gravitational forces that absorb matter, including light. In some cases, they can even consume stars in their entirety. However, the idea that black holes are behind the extinction of trillions of stars seems unlikely, as it would require an enormous number of black holes to account for such a vast disappearance, something inconsistent with what we currently know about these astronomical phenomena. The uncertainty surrounding this event has prompted a group of scientists to dive into historical research in search of potential explanations. So what do you think? Do you believe we need to reconsider many of the current theories in light of these new discoveries? Feel free to share your thoughts in the comments section. We also encourage you to support our content by liking, subscribing, and activating the notification bell. Your support motivates us to continue producing videos. Thanks so much for watching. We look forward to seeing you again in the next one. As these unexpected developments have reignited discussions within the scientific community about the very fabric of our universe. Could it be that our models, those we've relied on for decades, are incomplete or fundamentally flawed? As new data pours in from the James Webb Space Telescope, some physicists and cosmologists are advocating for a paradigm shift in how we perceive space, time, and matter. One area of increasing focus is the multiverse theory, the idea that our universe may be just one of countless others, each governed by different physical laws. While still highly speculative, the possibility of multiple universes offers a framework through which such massive disappearances or anomalies might be explained. Moreover, advancements in quantum physics may play a pivotal role in interpreting these findings. Some researchers argue that phenomena observed at the quantum level, such as entanglement or particles existing in multiple states, might scale up in ways we previously thought impossible, influencing large-scale cosmic structures in ways yet to be understood. Parallel to these theoretical explorations, technological innovation is accelerating. Next-generation instruments and observatories are being developed to extend the reach of our observations even further, beyond what the James Webb Space Telescope can achieve. Missions are underway to investigate dark energy more thoroughly, explore exoplanet atmospheres in greater detail, and measure gravitational waves with higher precision. The excitement is tempered, however, by a sobering realization: with every answer the universe provides, it also poses a dozen new questions. Each breakthrough brings with it a sense of wonder, and an acknowledgement of the vast unknowns that still dominate our cosmic landscape. For now, the James Webb Space Telescope continues its mission, scanning the heavens with unprecedented clarity. Its contributions are already reshaping textbooks and challenging deeply rooted assumptions. What lies ahead is uncertain, but thrilling. As we stand on the brink of possibly rewriting the story of our universe, one thing remains clear: the pursuit of knowledge is eternal. Whether we confirm our long-held beliefs or append them entirely, the journey itself is what drives science forward. Stay tuned, stay curious, and never stop asking, what else is out there? Collected and analyzed, we may find ourselves on the verge of uncovering a new cosmological model that is superior and explains the evolution of the universe, the behavior of dark matter, and the unknown forces that continue to influence the role of science in the universe. Instruments like the James Webb Space Telescope, in this quest for knowledge, cannot be overwhelmed by its advanced capabilities that are unmatched. The telescope is allowing scientists to probe the depths of space in ways that were once unthinkable, but now, discovery challenges us to think differently regarding the cosmos and forces us to question long-held assumptions about the nature of space, time, and matter. But the questions raised by means of these discoveries are not only academic, they have profound implications for how we think we fit into the universe. If fundamental laws of physics, like the conservation of mass, are shown to be more complex or variable than we thought, the entire framework of our scientific expertise may be required for a similar re-evaluation. If dark energy or dark matter behaves in ways we don't yet fully comprehend, we might need to rethink not only our models of the cosmos but also the very nature of reality itself. In light of these potential paradigm shifts, it's important to continue asking questions openly and with critical analysis. Science is a constantly evolving process, and advancements frequently result in more questions rather than answers. As our means of technologies improve, so too will our comprehension of the universe. As challenges arise, we must be ready to adapt our theories, embrace new ideas, and explore the unknown with an open mind. The implications of the James Webb Space Telescope's discoveries, made while it was unfolding, promise to transform the field of cosmology in ways we can't yet fully predict. With each new discovery we make, we are reminded that the universe is far more mysterious and complex than we ever envisioned. And as we continue to discover its secrets, we may find that the story of the cosmos is far from finished. Indeed, it may only be the beginning for us. We invite you to join us in this exciting journey of discovery. If you're as captivated by the wonders of the universe, you must remain updated on the latest findings from the James Webb Space Telescope and other groundbreaking space missions. Share your thoughts with us in the comments, and don't forget to like, subscribe, and hit the alarm clock to keep an eye on all our content. Your support is what keeps us going, which we value even more than you know. Thank you for watching, and we anticipate sharing more fascinating insights with you in the next video. The universe is waiting to be explored, and together we can uncover its most profound mysteries. As we embark on this continued exploration, it's clear that the discoveries made by the James Webb Space Telescope are just the tip of the iceberg, and the lessons it teaches have not only shed light on brand new aspects of the universe but have also prompted deeper philosophical questions about the nature of reality, space-time, and the fundamental forces that govern the cosmos. The telescope's ability to peer further back in time to the earliest moments of the universe provides a fresh perspective on the formation of galaxies, stars, and even planetary systems. With each observation, new doors open to understanding, and with it, the potential for radical changes in our scientific worldview. The startling revelation of the disappearance of over 771 trillion solar systems is particularly noteworthy. This event raises several critical questions that challenge both our current cosmological models and our fundamental understanding of physical laws. It's one thing to observe distant celestial phenomena and theorize about their implications, but when it comes to evidence that something as fundamental as the conservation of mass could be more complex than previously thought, theories once considered solid may require new evaluation or even be thrown out as a result of these findings. This opens the door to new, more comprehensive models of the universe's evolution. The implications of these discoveries extend beyond academic curiosity. They challenge the very foundation upon which modern astrophysics has been built. If the disappearance of these solar systems isn't a fluke or a misunderstanding, we must then take into account the possibility that our understanding of the universe's structure and behavior is incomplete. Could it be that the laws governing matter and energy are more flexible than we thought, or is there an entirely new force or phenomenon at work that we have yet to fully grasp? While these questions remain unanswered, the scientific community is approaching them with the same rigorous methods that have resulted in numerous other breakthroughs. Observations are being made, data is being analyzed, and hypotheses are being tested. Even as we grapple with these mysteries, we are reminded that science is a procedure that constantly changes. Our theories and models don't stay the same forever, they are dynamic and subject to change as we continue to learn more about the cosmos. One of the key benefits of the James Webb Space Telescope's observations is its aptitude for universe observation in different wavelengths of light, allowing scientists to learn more about specific areas of space that were previously obscured. This capability provides a clearer, more detailed picture of the universe's origins, evolution, and ongoing changes. The results of the telescope are not only filling in gaps in our knowledge but are also challenging old assumptions about how the universe functions. These groundbreaking observations are painting a more nuanced picture of the cosmos, one that defies simplification and demands a re-examination of the principles we've long held as truths. As the James Webb Space Telescope continues to collect data, it reveals patterns and anomalies that prompt deeper investigation. For instance, the formation of galaxies at unexpectedly early stages in the universe's timeline suggests that our models of galactic evolution may be missing key components. Were conditions for star formation vastly different than we believed? Or are we seeing the effects of unknown variables influencing cosmic development? Each answer brings forth new questions. As scientists map out distant exoplanets and identify atmospheric signatures that could hint at life, the line between science and philosophy blurs. Are we alone in the universe? If not, what does that mean for our place in the grand scheme of existence? These are not just scientific inquiries, they are existential ones that touch on human identity and purpose. The more we learn, the more we realize how much remains hidden. Vast voids, gravitational anomalies, and unexplained cosmic accelerations all point toward phenomena that are yet to be fully understood. The concept of a multiverse, once considered purely theoretical, now finds subtle support in some of these observations, leading researchers to explore realities that could exist beyond our own. And yet, amid all this complexity, there is a kind of beauty in the mystery. Science is not just about answers, it's about the courage to face the unknown with curiosity and humility. The James Webb Space Telescope represents not only a technological marvel but a symbol of our collective quest for truth. It reminds us that discovery is a journey, not a destination. As we move forward, collaboration between nations, institutions, and scientific disciplines becomes more vital than ever. The universe doesn't belong to one country or one field of study, it is a shared legacy, and unlocking its secrets requires unified effort. Every researcher, engineer, observer, and thinker contributes a piece to the cosmic puzzle. And so, as the data continues to flow, so too does our responsibility, to remain open, to question boldly, and to inspire the next generation of explorers. What lies beyond the edge of what we know may redefine everything, from the birth of time to the fate of existence itself. Would you like me to continue with another section focused on future technologies, philosophical implications, or a call to action for viewers?